Hi everyone, my name is Ryan and I'm a software engineer on the accessibility team. Today, I'm excited to be talking about some strategies to prepare your app for accessibility nutrition labels. Apple products are designed with everyone in mind, with an extensive list of built-in features. These features help people customize the ways their devices work to meet their needs. Some of these features fundamentally change the ways that people interact with their device, and others change how color, text, and other UI appears. Many have APIs that allow you as developers to check these preferences, like text size or increase contrast. With accessibility nutrition labels in the App Store, you can indicate which features your app supports. This empowers people to be confident that your app will work for them before downloading it. There are 9 accessibility features that you can indicate support for with accessibility nutrition labels across a range of categories. You can indicate your support for VoiceOver and Voice Control, 2 assistive technologies that offer different interaction methods within your app. You can also indicate whether your app supports 5 different visual accessibility features: sufficient contrast, dark interface, larger text, differentiate without color alone, and reduced motion. And if your app features media like audio and video, you can indicate support for captions and audio descriptions. Today, I'll go through a few of these areas and go over some specific APIs that you can use to make your apps more accessible as you extend your support for more accessibility features. I'll begin by discussing the different interaction methods and the considerations you'll need to keep in mind to allow people to interact with your app even without sight or touch. Next, I'll explore ways you can adapt your app for larger text sizes. Finally, I'll talk about ways you can make sure that your app's use of color is accessible to everyone. All right. I'll start by going over a couple of the different ways that people with disabilities might use accessibility features to interact with your app, and what you can do to make your app more accessible for them. VoiceOver is a built-in screen reader that describes what's on the screen with spoken audio, sound effects, and haptics, or with Braille. When someone using VoiceOver touches the screen, focus moves to the item under their finger.
Collections button.
And swiping right and left moves the focus to the next or previous item on the screen.
Map button. Landmarks button.
Double tapping the screen activates the focused item.
Featured landmark Mount Fuji button.
And there is a rich set of multi-touch gestures that can be used to control VoiceOver, such as swiping with 3 fingers to scroll,
Page 2 of 3. Australia/Oceania. Heading.
twisting with 2 fingers to select a rotor to move between things like containers or headings,
Containers. Headings.
and swiping vertically to move between options in the selected rotor.
Europe. Heading. North America. Heading.
Voice control allows people with motor disabilities to fully navigate their devices with voice commands without needing to touch the screen. Items on the screen can be shown with labels or with numbers, or they can have no annotations. People using voice control can speak commands like tap Mount Fuji, scroll down, and go back. VoiceOver and voice control are the 2 alternate interaction methods with accessibility nutrition labels. But there are several other ways that people may interact with your app. With switch control, people can use a button, joystick, game controller, or even mouth sounds and face and hand gestures to control their devices. People can connect a hardware keyboard to iPhone, iPad, Apple Vision Pro, or Mac to fully navigate their device with full keyboard access. And with head tracking and eye tracking, people can control a cursor on their screen by moving only their head or eyes. These features all rely on the same underlying system and APIs to expose items in your apps to the assistive technologies. So to narrow your focus, I recommend starting with VoiceOver. Having good support for VoiceOver should get you most of the way there to providing a good experience with voice control and other interaction methods. A great initial check to do with VoiceOver is to swipe through the screens of your app and make sure that VoiceOver can focus on all content. There are 3 main pieces of information that VoiceOver should read where applicable: the label, a name for the element; the traits, what the element's role is; and the value, what the current state of the element is. For example, I'm working toward another badge in the Landmarks app, and I'm checking the activities I've completed so far. When focused on this completed activity, VoiceOver says, "Read the landmark description, completed, button." Read the landmark description is the label, button is the trait, and completed is the current value of this item. I'll go over each of these in more detail later. Before doing that, I want to point out that if you're using default system components and controls for things like buttons, sliders, and toggles, I have great news for you. System frameworks will provide a strong foundation with built-in accessibility for system controls. You'll just want to consider how VoiceOver reads your content in these views, like providing labels to describe images, or adding heading traits to text that you add visual weighting to. And if you're creating custom controls, there will be more that you need to do yourself. To set what VoiceOver reads as the name of an element, use the accessibility label modifier, or set the accessibility label property on a UI view. Text views will automatically have an accessibility label matching their text. But for images and graphics, you may need to set a label yourself. A good label should include any text within the element and describe what is shown. For this picture of Mount Fuji from the Landmarks app, a good accessibility label might be "Vibrant cherry blossoms frame a snow-capped mountain rising in the background." For buttons with images, the label should describe what the button does, not what the icon is. For the heart-shaped favorite button in Landmarks, a good label is favorite rather than heart. The label should also not include the role of the element, like image or button, which will automatically be read by VoiceOver if you are correctly setting accessibility traits. By default, people using voice control can refer to an element by its accessibility label. If there are multiple words or phrases that someone might use to refer to an element, you can specify several options with accessibility input labels. In this example, someone could say tap favorite, tap heart, tap like, or tap love to activate the favorite button. Accessibility traits help describe what an element is, or what it does. For example, whether it's a heading, a button, or an image. All of these and more can be set with the Accessibility Add Traits SwiftUI modifier, or by setting the UI view's accessibility traits, and VoiceOver will announce the role in a consistent way. For example, text that serves as a header often has visual prominence, like a larger or bolder font. The header trait conveys that same information to people who rely on VoiceOver. For most traits, all you need to do is set the accessibility traits property. But one trait in particular requires some extra implementation to define behaviors for adjusting an element's value. I'm adding a new feature to the Landmarks app so that I can rate each landmark that I've visited on a scale from 0 to 5. The adjustable trait is implemented by SwiftUI and UIKit for slider views. For the slider to add my rating, VoiceOver reads, "Rating, 4, adjustable." Swipe up or down with one finger to adjust the value. If you're using a custom component, you'll need to define what happens when someone swipes up or down. In SwiftUI, add the Accessibility Adjustable Action modifier and handle increment and decrement cases. In UIKit, you can add the adjustable trait and implement the accessibility increment and accessibility decrement functions. An element with a value that can be changed, like a slider or text field, should use accessibility value for the value that's being set. while keeping accessibility label as a description of what the value or field represents. For example, when updating the name of a collection in the Landmarks app, VoiceOver reads Title, Towering Peaks, text field. Title is the accessibility label, the name of the field that I'm setting. Towering Peaks is the accessibility value, the current value of the field. And text field indicates its trait. So far, I've covered how you can make sure all of your app's content has a label, value, and traits. But you might notice as you use your app with VoiceOver that some screens take a lot of swipes to get through all the content, or that it's difficult to understand how different elements relate to one another. As long as all content and functionality is available to VoiceOver, it's actually okay for VoiceOver to not focus on each element individually. In fact, sometimes you can significantly improve how easy it is to navigate and understand your app by hiding or combining elements. One case of this is decorative images. Images that may help add visual context, but don't necessarily provide additional useful information when spoken by VoiceOver. Often, these are images accompanied by text that conveys the same meaning. For example, when I'm adding landmarks to a collection in the Landmarks app, the important thing to know is which landmarks I've added. The images can help sighted people to more quickly find what they're looking for, but for VoiceOver, the description of the image is less relevant in this screen, and people can already hear the full description of the image when they view the detail page for the landmark. In this case, VoiceOver should not focus on the thumbnail image and the text separately, which only adds extra swipes and extra verbosity.
Select button. Mount Fuji. Vibrant cherry blossoms frame a snow-capped mountain rising in the background. Image. Mount Everest. A snowy mountain peak is illuminated by the rising sun. Image.
To prevent VoiceOver from focusing on a decorative image in SwiftUI, use the Image Decorative Initializer or set Accessibility Hidden to True. In UIKit, set Is Accessibility Element to False. With this change, checking which landmarks are in my collection is much more streamlined.
Select button. Mount Fuji. Mount Everest. Rocky Mountains. Kirkjufell Mountain.
Another time when it may be preferable for VoiceOver to not focus on each individual element is when there is a visual or logical grouping between multiple views. For example, when multiple text elements are put in a stack for a certain visual arrangement. If visually someone would read them together, you should make sure that VoiceOver reads them together also. I'm working on a new feature for the Landmarks app to show flights to landmarks I'm interested in visiting. My view shows information about the origin and destination airports, as well as information about the departure or arrival time. VoiceOver reads each view individually, which takes a lot of swipes to get through and is difficult to understand how all the information fits together.
Arriving in. SFO. Airplane departure. Image. HND. 15 minutes.
I can use Accessibility Element Children Combine on the entire stack view to group it together for VoiceOver and automatically combine the labels of the child views.
SFO 2 HND arriving in 15 minutes.
All right, now I'll put it all together with an example. I'm updating my view to rate landmarks from a slider to an H-stack with 5 stars that you can tap to enter your rating. By default, VoiceOver focuses on each star separately. Even if I set a label for each star to indicate whether it's filled or empty, it's difficult to understand what's going on and what the current rating is.
Filled star image. Filled star image. Filled star image. Filled star image. Empty star image. Empty star image.
For a more cohesive experience with VoiceOver, I want VoiceOver to focus on this entire control as one element, with an easy way to adjust the rating. If I combine this into one accessibility element, set the label and value, and add an adjustable action to increment and decrement the rating, now it is much easier to navigate and understand with VoiceOver.
Rating 4. Adjustable. Swipe up or down with one finger to adjust the value. 3, 2, 3, 4, 5.
With the changes I just made, VoiceOver is essentially just treating this like a standard slider. If there is a system equivalent to your custom control, there is also a powerful SwiftUI modifier that you can use to have your custom controls inherit accessibility behaviors from the system version. In the same example I just showed, if I apply the accessibility representation modifier with a system slider view, VoiceOver will automatically apply the proper label, value, and adjustable behavior, making the rating component behave in the same way I just showed. One more important consideration is to review any custom gestures in your app. Most places that you're using UI gesture recognizers or SwiftUI gestures, you'll need to do some accessibility work also. Some apps might use single tap gestures for interactive elements instead of button or link views. But sighted people may still be able to use visual indicators like color or symbols to tell that the element is interactive. For example, you might have text that says "Learn more," has your app's accent color, and is accompanied by a chevron symbol. But if it just has a tap recognizer rather than truly being a button, VoiceOver won't announce it as a button. If you do this, make sure that you add the button trait so that people using VoiceOver can also know that it is interactive, even without seeing the visual indicators. Remember that gestures are mapped differently with VoiceOver, and people using voice control may not be able to touch the screen. So if you have gestures with multiple taps or touches, or with swipes or drags, there needs to be an alternative way for people using VoiceOver or voice control to perform the same action. I added a quick way for people to add landmarks to their favorites by double tapping the image at the top of the detail page. I can use the accessibility action modifier to allow VoiceOver to access this same functionality in the actions rotor. To go even deeper on accessibility custom actions and other SwiftUI accessibility modifiers, check out Catch Up on Accessibility in SwiftUI from WWDC 24. Next, I'll talk about supporting larger text sizes. Vision is a wide spectrum, and increasing the text size is one of the most commonly used accessibility settings. Some people may have had some degree of vision loss for their entire life, while others may be finding they need to increase the size a bit as they get older. To make sure everyone can view the content in your app at their preferred text size, it's important that your content scales with dynamic type and does not truncate or overlap. In display and brightness settings, people can increase the text size from the default 100% up to 135%. If you go into display and text size settings under accessibility and turn on larger accessibility sizes, you can increase the text size up to 310%. To add larger text support to your accessibility nutrition labels, you should make sure that your app works well up to a minimum of 200%. The best way to make sure that text in your app scales with dynamic type is to use standard system font styles like title, headline, body, and caption. These fonts automatically adapt to the device's text size setting. For example, a body font at the default text size on iOS is a 17-point font, while it scales up to 28 points at the first larger accessibility size, and all the way up to 53 points at the largest accessibility size. Note that different font styles scale at different rates. Titles are large to begin with and don't need to scale by as large of a multiplier as a caption font, which starts off small. While the exact percentage change at a given text size is not identical for all font styles, the relative size of font styles is maintained across all text sizes. To use these system font styles in SwiftUI, just use the font modifier with one of the predefined styles, and your text will automatically scale as the text size setting is adjusted. In UIKit, set the font with uifont.preferred font for text style, and set adjusts font for content size category to true to have the text automatically scale. If you use custom fonts, you can also have them match the auto-scaling behavior of system font styles. In SwiftUI, just use the font modifier with a custom font and specify the name, size, and what font style you want to scale relative to. In UIKit, create your custom font and then use UI font metrics for the text style you want to scale with to set your label's font. Remember that different font styles scale at different rates, so make sure to use a text style that is similar in size to your custom font. When designing an app, it's common to work with designers to produce a detailed specification and then build to match it. Having good support for larger text sizes starts at the design stage. Make sure the entire team understands that text can scale based on preferences, and layouts may need to change based on dynamic type. This is a process that happens all the time here at Apple. Designers start by providing an initial spec for roughly how things should be laid out, and then we'll follow up with more specific metrics for different text sizes and how layouts should change if needed. Take Control Center, for example. A 1x2 control can show the name of the control, but the layout doesn't allow much room for the text to grow. At larger accessibility sizes, these controls can grow to 1x4 to give text more room to expand across the width of the screen. If you've encountered challenges from inflexible designs that limit your support for dynamic type, I encourage you to make some improvements to your design process. The Human Interface Guidelines for Typography have specifications for what size text will be for each style at each setting, which can help figure out a good mapping for how the fonts you use in your app can scale. Once you're using fonts that can scale, Xcode previews are a great way to test how different screens in your app respond to dynamic type. You can easily add previews for different text sizes to identify where text may be truncating or overlapping. I'll go through an example of how I can use Xcode previews to identify and fix large text bugs. I'm adding a new screen to the Landmarks app to congratulate people when they earn a new badge. I have a VStack with an image, a title, and a message in the middle of the screen, and 2 buttons at the bottom. At a default text size, this fits comfortably. But to make sure it continues to fit with larger text, I'll turn on dynamic type variants in the Xcode previews canvas. Now, I can see my view rendered at every text size. Starting at the 3rd larger accessibility size, my message text is getting truncated. One thing that I might first think of doing to fix this truncation is to set the text to be fixed size in the vertical direction, so it will always take up as much vertical space as it needs. But this just shifts the problem. Now, my image and buttons are getting pushed off the top and bottom of the screen. Even when your views appear to fit comfortably on the screen at the default text size, it's always a good idea to have your content embedded within a scroll view, so content doesn't get pushed off the screen at larger text sizes. When I add a scroll view, I can scroll to reach all content at larger text sizes. But I notice that at smaller text sizes, now my stack view isn't taking up the full height of the screen, so the buttons are no longer anchored to the bottom. To fix this, I can move my buttons to a safe area bar modifier to pin them to the bottom of the screen. Now, I've achieved the look I was going for at smaller text sizes, while still having no truncation and being able to scroll to reach all content at the largest accessibility text size. But the last thing I notice is that with a smaller text size, the scroll view is still bouncing, even when it doesn't need to. I can add the scroll bounce behavior modifier with the based on size option to fix this. Now, this screen works well at larger text sizes while still looking and behaving the same at smaller text sizes. Another technique to ensure that text doesn't truncate is to make sure you set the line limit in SwiftUI to nil, or the number of lines in UIKit to 0. This allows text to grow to as many lines as needed to fit your text. It's okay for text to limit the number of lines and truncate as long as there's a way to view the full text by tapping to expand or open it in a new page. Consider also changing the axis of your stack views at larger text sizes to ensure content can fit more comfortably on the screen. In the example I showed earlier with flight arrival times, text starts to wrap and is hard to read when using larger accessibility text sizes. If I change the main stack to be vertical instead of horizontal, and the arrival time to be laid out horizontally instead of vertically, the information is much easier to understand. For more examples and details on how to implement better support for dynamic type, check out Get Started with Dynamic Type from WWDC 24. Finally, I'll talk about color and some key considerations when it comes to accessibility. Color is a great way for your app to stand out and express itself, and to help people understand the information displayed in your app. However, it's important to take into account that different people may perceive color differently, and some people may need more contrast in order to perceive and read the content in your app. People can turn on the Differentiate Without Color setting to request that apps use more than only color to differentiate between UI elements. You can check the Accessibility Differentiate Without Color environment value in SwiftUI. Or in UIKit, check UIAccessibility.ShouldDifferentiateWithoutColor and observe the Differentiate Without Color did change notification for changes. One example of a place where it's important to support this setting is in charts showing multiple data series. Here, I'm plotting the number of visitors per month for a couple of my favorite landmarks. I'm already setting different foreground styles or colors for the different data series, but this relies only on color to tell them apart. This is implemented as a Swift chart that includes line marks and point marks for my data series. With the symbol by modifier, I can easily customize the symbol used for point marks to add more visual distinction. Now, the different data series on my chart have different colors and different symbols. For many people with low vision, dark mode is an important accessibility feature. For people who are sensitive to light, bright white backgrounds can wash out other content on the screen, so having white text on a dark background makes it easier to read the content. Just like how system controls give you a head start on making your app more accessible with VoiceOver, system colors automatically adjust for light and dark mode, making it easy to support both. You can use semantic system colors like primary for text, which automatically adjusts to be black and light mode and white and dark mode. And even other system colors have slight differences between light and dark mode to maintain higher contrast against the standard light or dark background in each mode. Some colors have more pronounced differences than others, but all of the dark mode versions are slightly lighter than their light mode counterparts. By lightening foreground colors in dark mode, you can help improve their contrast against the darker background. If you use custom colors in your app, you can define light and dark mode variants for the color when you add it to your asset catalog. When you use these colors in your app, they will automatically adjust, just like the system colors do. Here, I'm adding custom colors for some of my landmarks, with a darker brown for Grand Canyon in light mode, and a lighter version for dark mode. When you test your app for sufficient contrast, make sure to test in both light and dark mode. Start by ensuring high contrast levels with reduced transparency and increased contrast enabled. Accessibility Inspector is a tool that ships with Xcode and has a built-in color contrast checker that you can use to check the contrast ratio between background and foreground colors. liquid glass is a key part of the new design system. When considering the accessibility of your app with the new design, liquid glass automatically provides a number of adaptations according to the needs and preferences of someone using your app. It dynamically adjusts for different backgrounds and adapts to dark mode to improve legibility. There's an option to choose a clear appearance or a tinted appearance that allows less of the background to show through. And when accessibility settings like reduced transparency and increased contrast are turned on, it becomes even more opaque. Liquid glass, blurred toolbars, and other system materials will automatically become fully opaque when the reduced transparency setting is enabled. If you're creating transparent views on your own, check the value of the setting to make your views opaque. This way, you can prevent text or other content from the background from showing through and interfering with the legibility of foreground content. In SwiftUI, the Accessibility Reduced Transparency environment value will automatically update when the setting changes. In UIKit, check UIAccessibility.isReducedTransparency enabled and observe the Reduced Transparency Status Did Change notification to respond accordingly when the setting changes. Just like with dark mode, system colors will automatically adjust to higher contrast versions when the increased contrast setting is enabled. If you need to customize the colors you're using in your app to maintain sufficient contrast when increased contrast is enabled, check the value of the setting to adjust your colors. In SwiftUI, the color scheme contrast environment value has an enum value of standard or increased. In UIKit, you can check the accessibility contrast property in the UI trait collection and register for trait changes to know when the setting is updated. Reviewing the same set of system colors from earlier, this time with increased contrast on, the light mode variants get darker, while the dark mode variants get lighter. In general, with increased contrast enabled in dark mode, foreground colors should get lighter for more contrast against the dark background. And in light mode, foreground content should get darker to have higher contrast against the light background. If you use custom colors in your app, you can also define standard and high contrast variants for the color when you add it to your asset catalog. When you use these colors in your app, they will automatically adjust just like the system colors do. Here, I've updated my Grand Canyon color to be an even darker brown in high contrast light mode and a lighter earth tone in high contrast dark mode. All right, there's a lot to consider here. A good first step, if you haven't already done so, is to evaluate the current state of your app's accessibility. Define some of the key tasks people need to be able to complete in your app and test them out across the categories of accessibility nutrition labels. Remember, if any individual view in your app is not accessible, it could make your entire app much more difficult to use for people who rely on accessibility features. Check out Evaluate Your App for Accessibility Nutrition Labels from WWDC 25 and the Manage App Accessibility section of App Store Connect documentation for minimum criteria for what your app needs to do before you should indicate support for each feature. Be sure to pay special attention to any custom controls and gestures you use as you make sure that people who rely on VoiceOver can fully navigate your app. Adopt text styles that can scale with the text size setting, working with your design team if needed to make sure that text scales without truncating or overlapping. And review your use of color to ensure you have sufficient contrast throughout your app in both light and dark modes. Accessibility is a journey. There's always going to be more room to improve, but if you keep accessibility in mind when working on your app, you'll find that you can quickly make incremental progress. Aim to make some accessibility improvements with every release of your app, and update your accessibility nutrition labels in App Store Connect as you add support for more features. Thank you.